In the last video, we spoke about how this approach to the approve request function doesn't quite work out. Remember, it all comes down to the fact that we are using arrays to store these addresses, and those arrays are growing without bound. Because we are always going to iterate through the full length of our arrays, we might end up having to spend a tremendous amount of gas in order to look up some given address inside of the approver's array and the array that keeps track of who has voted on a given request. We're now going to pivot and start looking at the solution that we're going to actually use inside of our contract. So we looked at the way in which these things don't work out. We looked at the problem. We're now going to look at how to solve it. So everything from here on out is the right way of writing this code. In order to solve this issue, we're going to stop using arrays altogether inside of our contract, and we're going to instead use a slightly different data structure. The data structure that we're going to use for storing all these addresses, rather than being an array, is going to be a mapping. We spoke about mappings a little bit many videos ago. A mapping is a reference type that is available to us inside of Solidity. You can think of a mapping as being like a collection of key value pairs, and so effectively it's very similar to a JavaScript object. There are some very discrete and definite differences between a mapping and a JavaScript object, and we'll talk about exactly what those differences are in just a little bit. First, however, I want to talk about why a mapping is going to solve our issue here. Okay, so let's talk about exactly why it's going to solve our problem. So it all comes down to the search time for each of these data structures. Before, we were using an array, and we're now saying that we're going to use a mapping. In computer science lingo, we can say that whenever we want to try to do a search or find some piece of data inside of an array, the best case that we can get for running that search will be linear time. Again, this is a little bit of computer science lingo right here. When we say that search inside of an array is linear time, that means that for every additional record that we add to this array, it's going to take a slightly larger amount of time to execute a search. So if we have 10 records inside of an array, it might take 10 seconds to search through. And if we have 100 elements inside of an array, it might take 100 seconds. In other words, the size of the array dictates how long the search is going to take. And that's exactly what ran us into some trouble in the last video when we started thinking about gas prices. The big difference between an array and a mapping is that doing a search inside of a mapping is what we refer to as constant time. That's another piece of computer science lingo. When we say constant time, that means to say that no matter how many pieces of data we are storing inside this mapping, it's always going to take the exact same amount of time to execute a search. So in other words, if we have one contributor inside of our campaign, it might take just 1 second to look up that given contributor. If we then later on have, say, 10,000 contributors inside of our mapping, it's still going to take only 1 second to look up a given contributor. So it doesn't matter how many people enter into our contract, it's always going to take the same amount of time to check to see if they have donated and check to see if they have already approved or disapproved a given request. So that's why it's going to solve our issue here. It all comes down to the computer science-y part of these data structures. All right, so clearly we definitely want to use mappings here. Let's pause right now. We're going to continue in the next video, and we're going to start to discuss exactly what mappings are and how they differ from traditional JavaScript objects that we might already be used to. So let's take care of that in the next video.